The following videos describe the specific features of controls and layouts when compared to their known use. In particular, this is related to 5 aspects: the special features of variable or attribute controls in relation to tags, the use of tables, and the special features of the image control, the special features of grids in relation to the design and behavior of each line, the possibility to change a control type so that it looks and behaves in a different way than the default one, section containers for the detail of a work with element, and lastly, the possibility to create a control that takes absolute positioning and can overlap with another in the layout. This allows thinking in layers, and therefore adds depth to the spatial axis. In addition, we will see this feature combined with another related to behavior: the ability to move, resize, rotate, and scale a control on the screen. These are the transformations. Let's start with the first item. Two areas constitute a layout: the area known as application bar, where buttons can be placed, with or without associated images, corresponding to actions to be performed, or containers of groups of actions, group control, to group several actions and offer them, for example, as drop-down menus. Here you will find more information about this topic. The second area is the layout itself, which offers the toolbox to insert controls. For the detail node of the work with element, placeholders will also be displayed, as we will see later on. We'll focus on this second area and leave the first one for later when we study events. For controls of attributes or variables, we have the label position property. This will allow indicating the position that will take this attribute or variable tag. Each platform has a default value. In Android, for example, it is top. This means that the tag will be displayed above the attribute variable control. It's different from what we see here, where it's shown to the left. The reason is that it has to be shown in some way, and the screen is generic, not platform specific. Let's see it in GeneXus. We're positioned in the list of the work with for smart devices element of the speaker transaction. Note that the pattern has automatically added the speaker name attribute control to the grid. If we look at its properties, we see that the label position property takes the value none. For this reason, there is no tag displayed for this control. We will replace this control corresponding to speaker name with the speaker's full name. To do so, we delete this control and right-click inside the grid. We select Insert, Attribute, and add Speaker Full Name. Note that the tag is now displayed by default. To hide it, we go to Label Position and change the platform default value to none. Now we will add the speaker's country name. We right-click again or drag the attribute variable control from the toolbox, country name. Again, in the properties we change the label position value to none. We press F5 to test what we've done. Since we don't have a startup object defined, the Web Developer menu and the KBN were opened. Note that it can be divided into 2 columns and 2 rows per line in the grid. How do we change the place taken by controls within each row and also their distances? By working with tables, which will be essential in smart device applications. All layouts have a root table, even when they're empty. In turn, every grid will define a table to contain the controls of each line to be loaded. In this case, the table has 2 columns and 2 rows. Look at the 2 properties, column style and rows style, which allow defining the size that each column and row will take in the table. Now look at the columns. Their sizes can be specified in two units, percentage or DIPS, device independent pixel. Note that the Style tab shows how it will look at runtime. In the columns, this 50% is visually clear. The device independent pixel unit corresponds to the abstraction of 1 pixel, which later an application converts to physical pixels in order to scale to different screen sizes. The DIP value has a different number of pixels for each platform. Percentages are relative to the value resulting from subtracting the total width. Fixed values are expressed in DIPS. In this way, the total width is 240 DIPS, and there's a column of 64 DIPS. The value 100% for the next one means that the second column will take the remaining 100%. That is to say, 240 DIPS minus 64 DIPS equals 176 DIPS. If we had 3 columns, the first one of 20%, the second one with a fixed value of 5 DIPS, and the third one of 80%, the values that the first and the third one would take would be obtained by applying these percentages to the value resulting from subtracting the sum of the fixed values. Here we have only one, 5 DIPS of the table width. The second column of 5 DIPS can be used as a blank space between the first and the third column. Let's customize this in GeneXus. We see that for the list, we have the main table and the table corresponding to the grid, table 1. In the columns, in this case we see that the first one takes 64 DIPS with the speaker's image, and the second one takes the remaining 100%. To graphically see how the form will look at runtime, we open the Style tab. Here we see this division into columns, with their sizes. 64 DIPS, and the remaining 100%. We will add a column between the first and the second one, so as to have some space between the contents of each column. So we right-click and select Insert Column. We look at their widths. A size was assigned to the column in the middle, PD, which we will see later. We will change it because we want that column to take 10 DIPS, which is a fixed size, and the first column to take 30% of the remaining width. The third one, logically, will take 70%. We can change it by writing on the property or opening this window. We run it with F5. If we now look at the rows, we see that we have 2 with value PD. It corresponds to the platform default unit. This unit varies with the platform. It is aimed at using the best value depending on the platform and the context. For example, for Android with label position equals top, this is 64 DIPS. Meanwhile, in iOS 7, it's 53. Here you can see all the values it takes. We will have our image spread across both rows.
Vamos a hacer que nuestra imagen se expanda en las dos
Above the
filas.
image, in Cell Information, Row Span, 2, and we then arrange controls so that they look as we wanted. F5. Suppose that now we want the table background to be black instead of gray. Also, When the user taps on a line, it should turn to blue, and the speaker's full name should also be displayed in blue. Where do we configure it? In the classes of each control, of the table control on one hand, and the attribute control on the other. So, for the table control, we will replace its predefined table class with the class table-colored blue front. For the attribute, we will change its attribute class to attribute front color blue. If we open the theme corresponding to the Android platform that we're running, remember that it was Event GX Android, and we look for these classes, we see that the class table-colored blue front is the one that takes the values we want for the properties background color and highlighted background of the table on one hand. And for the attribute, these two. F5. And here we see it. Tapping on an element changes its background color. Now let's pay attention to the shape of each image within the cell that contains it. Are these images being scaled? And if so, how? Let's look at the image control class, image. If we open this class properties within the theme, we can see that there's a scale type property that can take one of the following values. These values will determine the way in which the image is scaled, if it is scaled, within the control area that contains it. If we don't indicate anything, the value used is fit. This will cause the image's width and length to be scaled so as to fit in the space while keeping its original appearance. Remember that classes have been added to this theme. They only set this property in order to adopt one of the other values, fill. Fill keeping aspect ratio, or fit. Now suppose that we want to enlarge or reduce our image so that it occupies the entire cell. To do so, we will change the class to ImageFill keeping aspect ratio. Let's see it at runtime. And here we see a summary of what each value does. You'll find more information about this topic in our wiki. This is the end of the first item proposed in relation to controls and layouts. And now we will talk about the second one.